Welcome to lesson 49, and in this lesson we're going to work on one-step equations with rational numbers. In other words, we're going to see some decimals, we're going to see some fractions. The good thing is our criteria for success is the same as in lesson 48, that we could express a situation as an equation with variables, that we're using the inverse operations to isolate variables, and again, whatever you do to one side, you do to the other. Demonstrate that in your work, and finally that we're checking our work with substitution. Let's get some more practicing with one-step equations. This time, we're gonna have rational numbers, meaning we're gonna have fractions and decimals, which adds a little bit more rigor to the problem, but it's the same steps. And remember, we do have tools next to us if need be to confirm answers. So let's start with the first one, and we have 2/3 x is equal to 12. And like we said before, when we have a coefficient, we're going to use division to isolate that variable. And why are we using division again? Because when we divide a number by itself, we end up with just 1. So 2/3 divided by 2/3 is just going to give us 1. It doesn't matter that they're both fractions. 5 divided by 5 is 1. 100 divided by 100 is 1. 2/3 divided by 2/3 is just going to leave us with just 1x. And that's what we want. And whatever we do to one expression, we're going to do to the other one. So we're also going to do 12 divided by 2/3. So we're going to rewrite this the way we normally did when we divided by fractions. So 12 over 1. And we're going to rewrite this, change this to multiplication, and we're going to multiply by the reciprocal. So keep, change, flip. And that's going to give us 36 over 2. Simplify that, because I don't want to leave our final answer x equals 36 over 2. We want to make sure we put this in simplest form. So 36 divided by 2, if you're not sure, just do the math out. I will tell you it is just 18. You can test it if you'd like to. So I'm getting x equals 18. So this is the one answer that will make this equation true. When x equals 18, 2/3 x will equal 12. Now, getting back into habit, let's check our work. We take our original, 2/3 x is equal to 12. We're going to substitute for x. Because there's a coefficient, I'm going to use my parentheses, equals 12. And now we're going to simplify. So 2/3 times 18 over 1 is equal to 12. 2 times 18 is 36. So 36 over 3 is equal to 12. And we can simplify that more. 36 divided by 3 is equal to 12. So 12 is equal to 12. We confirmed it. Both expressions, are equivalent to each other. So you can hit pause and jot this one down into your notes. So again, rational numbers, the steps are the same, just the numbers are a little bit more complex, but we know how to work with these numbers. Let's go to the next one. This one looks a little different. Y divided by 3 is equal to 8 3/10. So, things I will tell you about this problem. One, it looks like a fractional form on the left, and we have 8 3/10 of decimal on the right. So how do we work out this problem? So let's think about another way to rewrite a number divided by 3. How else could you write that down? You could write it in this form. A number divided by 3 is equal to 8.3. That's one way. What I like about this way is you can think if a number is divided by 3 equals 8.3, you can rewrite this and say, well, then that number is equal to 8.3 times 3. So again, you're using the inverse operation to rewrite this and find the answer. So that's one way we can do this. I'm going to see this one through so you can see all of it. So y is equal to 24 and 9/10. And we can test this out. So a number divided by 3 is equal to 8 3/10. 24 9/10 divided by 3 is equal to 8 3/10. And you could actually just test out. 3 goes into 24 8 times. 3 goes into 9 3 times. So I do get 8 3/10 is equal to 8 3/10. So this is one way that works really well. Again, you're just rewriting the expression into a division, and then you're using the inverse to rewrite the problem. So this one works out very, very well. I do want to give you one more option. So hit pause for a second so you can jot this down. And I'm going to show you just one more way to do this now. Another way we can rewrite this problem. I want to give you different options. The more options you have, the more tools, the more decisions you can make, because you just know different things you can do. Some students will say, what else could I do to make this just a y on one side? And what some kids will do, and I'm going to actually show you, is to multiply this by 3/1. So why does this work? When I multiply these numbers together, 3/1 times y/3, I'm going to get 3y divided by 3 is equal to 8.3. Okay, that's all I did. I multiplied to get 3 times y/3. And now when I simplify this, what is 3 divided by 3, math marbles? 3 divided by 3 is only going to leave us with y on this side. But just remember, whatever you do to one side, you're going to have to do to the other as well. So if you divided this side by 3 here, you just have to remember to do it on the other side too. And once you can do that, you can simplify the same way we were doing. 8.3 times 3 is still going to give us 24.9. So both of these methods work. All I did here was I used my multiplication, and it's still an inverse, so I still see division, and I'm just multiplying by its opposite. Okay, math marbles, for these problems over here, we're going to use a calculator to help us out. I'm going to evaluate the same way we've been doing, but we're going to have positive and negative numbers. These are very easy places to make errors, and this goes back to our NS unit. So let's look at the first one. 1 2800ths plus a number is equal to negative 12 9/10. So again, I have a coefficient, so that means we're going to make a 0 pair. And to do that, I'm going to subtract 1 2800ths from both sides. And this will leave us with just a number on the left. And on the right, we have to evaluate this. What is 12 9/10 minus 1 2800ths? So I'm going to use my calculator for this. 12 9/10 minus 1 2800ths. And that's going to give us negative 14 1800ths. So again, does this make sense? Yes, because my number is just getting more negative. I have negative 12 9/10, and I'm subtracting further, so I'm getting a number further from 0. Let's do our check. I'm taking just my original. And now we're going to substitute for W, so plus negative 14 1800ths. And again, I'm just going to use my calculator to confirm 1 2800ths plus negative 14 1800ths is equal to negative 12 9/10. So both sides are equivalent to each other, so I know this one is correct. In the next one, we have a fractional one. So let's look at this one carefully. I'm even going to give ourselves more room. 3 1/8 minus the number is equal to -2 5/8. Okay, so same thing. I have a constant, so we're going to create a zero pair. I'm going to subtract 3 1/8. So this is going to leave us with just negative a number. And on the right side, I'm thinking about what we already know is becoming more negative. So as my symbol, when I have two negative numbers, I'm going to add them together. And that's going to leave us with -5 6/8. I want to simplify that since I know I like my numbers in very simple form. So I'm just going to do it here. Change it to 3/4. If -s is equal to -5 3/4, I don't want to know the negative. I want to know what that number actually is. So I'm going to multiply this by -1. Okay, so -1 times -s, a negative times a negative gives us a positive. And I'm going to do the same thing to the other side. I'm going to multiply by -1. And when I do that, I'm going to get s is equal to +5 3/4. Hit pause for a sec so we can jot this down. Awesome sauce. And let's go back to the original. 3 1/8 minus 5 3/4 is equal to -2 5/8. So looks a little dicey. That's okay. So again, we're going to do some subtraction work. We have a positive and a negative. So I'm going to just rewrite this. 5 3/4 minus 3 1/8 is equal to -2 5/8. Just doing that so that I know that these two are being subtracted. I know that I can't subtract 3/4 and 1/8, so I'm going to change this back to 6/8. Now I can subtract, so I'm going to get 2 5/8. So just remember, when I did this problem here, which one was the negative number? The bigger number over here was negative. So that means my final answer here is also going to be negative because I have more negatives than positives. So this is a true statement. So again, Math Marbles, lots of MS skills here, and that's what makes this more complicated. So please take your time. You may have to find that you have to review. But ask questions and check in with your peers. Check in with your peers and see if you're coming up with the same answers. If you have something different, look to see what's different about your work and talk about it together. Ask each other instead of defending and saying, I'm right because. Ask questions to understand how each of you understood the problem and what you did. So you're looking for that truth. Okay, so this is going to take a lot of practice, but it will get easier with time. Use your resources, which include your other people in the room, the adults in the room, and your notes. I will see you in the next lesson.